Hello everyone and welcome to my next self-study tutorial, and this is Leetcode number 104, the maximum depth of a binary tree. So for this problem we're given the root of a binary tree and we're to return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So typically when solving these sort of problems, what we want to keep in mind are the terminologies. For this problem, we're to return the maximum depth, and all that is asking for is the height of the tree. Yeah, so when we're solving these problems, we're not flustered by new terminologies. If we know how to solve one, we definitely know how to solve the other. So how do we solve this anyway in code? What we can do, we can use recursion. And with that, we know we're going to need a base case. If we don't have a valid base case, then we can end up with something known as Stack Overflow. And so for this case, since we're trying to find the depth, we're doing some additions here. So for our base case, whenever we encounter a node that is null, we just return 0. So otherwise, we're going to do some addition. We're going to add 1 for every node that we encounter. And we're going to make some continuous recursive calls on the left and right child of the current node. And we're going to get the max of these recursive calls, the result of these recursive calls. Yes, so looking at our code, we can see that our base case is on line number 13. And all that's happening here is that it's running a check to see if the root or the node is null or undefined. And if it is, we want to return a value of 0. And we are returning a value of 0 as the return type because we're doing additions. And we want the result type to match our operation. So otherwise, if it's not null, we're going to continue to do some additions for every node that we encounter, plus the max of the results of the recursive calls on the left and right children. And so we can see that this particular problem, when we write the code as dry as possible, it's only 2 lines of code. It's fairly simple and readable. And we're going to look into how this runs internally in the next section. But for now, if we proceed to an example, we'll see that we have our node object here with a left and right child as properties and a value as another property. And so we create our root as A. And so we're going to create a tree, A, B, C, D. And B and C are the children of root A, and D is the left child of node C. And so if we run this, we see that a value or our return of our maximum depth of this particular tree is actually 3. And looking at it, we can see it's indeed 3. So for these problems, as I mentioned before, we just need to keep in mind these terminologies so that we're not flustered and we are able to solve variations of binary tree depth and height problems. And that's it for that. What we're going to do next is go over to the drawing board and kind of look a little more in depth how this particular recursive function works internally. So see you there. So how does this work? Well, when we make our recursive call on root, it's not going to hit the base case, so it's not going to return 0. It's actually going to go to the next statement, and it's going to make some additional recursive calls on both the left and right children. In addition to that, we're going to keep on incrementing by 1 for every node. And that's how we're going to get our depth, right? So we're going to do the max of these calls. So what does that look like? All right, so let's create a box. And so for root, let's just have this as A just to represent the object in these squared brackets. And as we said, it's not gonna return 0 because root is not null in this case, but we're gonna increment by 1 plus some additional recursive calls. We're gonna get the max of each. So it's gonna be the make a call on the left child and the right child. In this case, it's C. Yes. Let's see if we can change the color so we can actually see this better. Okay. So for B now, B is also not null. And so it's going to go to the next statement, the max thereof. So, but B has no children. So it's going to be fn of null, right? And these calls are subsequently going to return 0 because they're going to hit the base case. So I'm just going to represent them by 0, 0 for each call, left and right. Now we go over to C. C is not null, so not going to hit the base case. And we're going to make calls on its left and right children. So that's D. And C has no right child, so that's null. Let's change that color. Okay. So for D now, the call on D, it's not null, but its children are null. It has no children, so it, and it calls on those. And as before, it's going to return 0, 0 for each. And even this line here for C, it's going to return 1 and 0. So how do we get that? Whoa, how do we get that? Okay, so when we hit D, we make calls on the children, the left and right of D. They're going to return 0. And so these values are going to be 0. The max of 0 and 0 is 0 plus 1. It's going to be 1, right? So now back tracing to C. So now D has already returned something. The fn of D has returned something. It returned 1, and it's represented here. And the fn of null, we know it's going to hit the base case, so it's going to return 0. So C is also going to return, it's going to return 2 because D returned 1. So 1 plus max of 1 and 0 is 1, so 1 plus 1 is 2. So C is going to return 2, right? So here now, we have 1 and 2. And we know that because B returns 1, because its children are null, it's a leaf. So that returns 0. Max of 0 and 0 is 0. 1 plus 0 is 1. So fn of b, it's going to return 1. And fn of c, as we discussed, returns 2. And so the max of 1 and 2 is 2. And 1 plus 2 is 3. So the fn of a is actually just going to return 3. So the result of this entire process is going to return 3 for this particular case or input. And this is just done with recursion. And the recursion makes this fairly straightforward to read. It can be very tricky, especially for base cases incorrect. But once we practice more and more of these recursive type of problems, we tend to understand, how it works internally. So, yeah. If there's something that I missed, please let me know in the comments below. If it was helpful to you, please let me know in the comments below. Like and subscribe. And thank you so much for listening. Have a good day.